Hey everybody, welcome to the webinar. People are streaming in pretty fast here, so we're just going to wait 2 minutes and we'll get started. Thanks for joining. All right, one more time for everybody that's joined within the last minute. We're going to wait 1 more minute and we'll get started. Thanks for joining. All right, it's 10:02. We still have a lot of people streaming in pretty quick here, but we're going to go ahead and get started. Welcome to the Domo Data Science webinar. I'm Andrew Chaffin. I'm a solution consultant and data science sales specialist here at Domo. I've been here 7 years. I came from the lab management and research area before coming to Domo, and I've loved statistics and analytics ever since I got my first p-value, which happened to be insignificant, but we won't dwell on that right now. Also, we have Dr. Christy Rowley. She's our principal data science consultant and the manager of our Domo Data Science Consulting team. She's going to be our main presenter today. She got her PhD from Vanderbilt, and she's been what we now call a data scientist. This was actually coined in 2001, introducing that term, and she's anyways, she takes a collaborative and educational focus with our clients. We've had great success in the engagements she's taken on so far with her team. She's worked with all clients from large multinationals to governments to scrappy startups, and she's built the data science consulting team here, and it's grown rapidly. They've been pretty busy. She's also published over 20 peer-reviewed articles. She's the owner and operator of her own private consulting practice. And while she's not doing all of that, she does her favorite thing, which is going on adventures with her 8-year-old son, Jackson. So as far as format for the webinar goes, we're using Zoom webinar. The presentation is going to be 30 minutes. Well, we're going to go to the bottom of the hour, I should say, so 27 minutes. And there'll be a 15-minute Q&A portion. So we do want your questions, and you don't have to wait to the end in order to send them. You can just go ahead and send them during the presentation. If the answer's like short and straightforward, I may just answer back through Q&A. Otherwise, we'll answer it in the presentation or in the Q&A portion at the end. The Q&A button is at the bottom of your Zoom window. If there aren't many questions, we may end early, but if there's a lot of questions, we may not get to all of them, as we do have to stop at 45 minutes. If you have questions we didn't answer, or if you're interested in learning more, just reach out to your favorite Domo contact or set up a call with us. So with that, Dr. Rowley, the time's yours.
Thank you. I'm excited to be here today, excited to talk to you today. And I'm excited to introduce to you our data science consulting and also our data science product that we use here at Domo. Here at Domo, we have a philosophy around data science, and that is that data science is part of your data journey. And we feel like we're on a data journey with all of our customers. We absolutely want to continue on that data journey with you. And for many of you, data science is the next step in that journey. And for us, data science is about a process. and that includes the people associated with the process plus the technology. So we emphasize both. We emphasize both business questions, building good business questions, building good data that support those questions, and then using technology to analyze your data, and more specifically, using data science to analyze your data in a platform that is conducive to production work, data production in Domo, and also automation around data science. As Andrew mentioned, we have built a team around data science at Domo. This is just a few members of our team here. And we focus primarily on teaching, and we also focus on collaborating with our customers around data science use cases. I want to share one of those data science use cases with you today. Before I do that, I'll spend just a few minutes introducing you to our team. Our emphasis in building our team has been around flexibility and expertise, and not just expertise in the data science realm, that's a given, but also expertise around business consulting. Really good business consulting leads to really good questions that we can answer with data science. Really good data architecture, and we have experts who can do that. And also, of course, because we're Domo, we want to have the very best Domo users we can possibly get on our team, which is what we've assembled. So we have expertise in many domains, and because of that, we have the opportunity to work with all sorts of different kinds of customers. So if you are a data scientist and you want to move some of your work into production in an environment like Domo, if you want to keep your data science where your data science or where your data live, which is in Domo, we can work with you. We can work with you on best practices. We can work with you on automation and creating data pipelines that are effective and quick and run quickly. If you are an analyst and you want to move forward with data science, we are all teachers. Many of us have taught at universities, and we have taught data science for many years. So for myself, it's 25 now. So we can work with anybody who doesn't have a background in data science or people who do have a background in data science, and we can help you and work with you to develop your ideal solutions around data science. If you're not sure you're ready for data science quite yet, and you want some diagnoses around whether or not you're ready for data science in your data journey, we can also work with you on that. We can help you point you in the right direction so that you're utilizing your resources in the best possible way to move forward on the front of data science. When we talk about processes plus technology, I want to highlight our process. The first step that we always do with our customers is we prepare their data, and then we take a look at it and really assess it. The best data science algorithms in the world are not going to make up for poor quality data. So we want to make sure that we're using the best data we possibly can, that we're cleaning it in the best possible way. We're making sure that we understand and know all of the assumptions we're making with those data, and then we can move on to the analysis phase. We will optimize models. We will run several different models, take a look at those, identify the most appropriate ones and the ones that are best for customer outcomes, review them with our customer, implement them, including in a production environment that is automated, and hand off the solution along with all of the training and the deliverables that we agree on at the end of the engagement. So that's basically what our process looks like if you work with us at Domo Consulting. Of course, there's the technology piece, and this is another place where Domo shines, and what you'll love about Domo Data Science is what you already love about Domo. Data science sits right between a great visualization engine and a really good data warehousing tool. And you never have to move data around to do your data science. You can do it right in Domo. As you can see here, we have a screenshot of a magic ETL data flow where we're using the R scripting tile. So you connect any one of those R tiles with an input data set. You write your script right in it. As you can see on the right-hand side, you can script whatever you want as long as you have an input data set and the output of that script is a data set, then you can script virtually whatever you want within that tile, and you can do the kind of data science that you want to do. So it's a very flexible tool, it's easy to use, it's intuitive, and it operates right there in Magic ETL. As a summary, we clean data, we focus on clean data, we develop the right model, we use a robust platform, which is Domo, and we drive insights and action around data science. So with that, let me move over to our demo instance, and I want to show you some of the work that our customers are doing around data science. And I'll walk through this in terms of how they would walk through it when they were engaging with our consulting team around data science. The first thing that we will do with the customer is go very deeply in depth on the use case that they want to do, the question, the problem they're experiencing in the business, further develop that, further develop the insights around that problem, identify how the data pipeline is lined up with that problem, talk about expectations for results, and go over a fairly in-depth 27 questions about what the use case is, what the problem is that you want to solve, how you want to solve that, and then what an ideal solution would look like at the end of it. So that is our first step. And once we understand that and we're all on the same page with what the limitations of data are, what the strengths and weaknesses are, what the best models might be, and how we can really address that use case and that question in a way that's usable to the business and to an end user, we'll move forward with identifying the data that are useful for that question. So here's what we call a metric map. We could do this in an outcome, generally speaking. So something that you care about, something you want to be able to manipulate. It could be revenue, for example. Some predictors, and those predictors are things that you can control, things that you can navigate. You can pull levers, or push them and manipulate them in some way to change that outcome. And those are important, especially when we're looking at predictive analytics, because those are the ones that are within your control, and therefore they're drivers that you can use to drive interventions. So those are something that we can measure and look at. The last thing that we'll do is account for your control variables. Ironically, control variables are things that fall outside of your control, but things that you want to account for because you know they influence the outcome. And that helps us get the best model we can possibly get. We will work with customers to identify a lot of different aspects of their data to get the best measures that we possibly can to drive a model that will work for you and your business. After we get that, we'll profile the data. And what this means is we're going to look at every variable that matters in this predictive relationship. And we're going to take a look at the structure of it. We're going to look at the shape of it. Is it normally distributed or is it not? We're going to look at missing data. We're going to look at granularity and see whether or not things that are measured at specific points in time are always measured in the same way across time. The time series analysis tends to be really useful. In this particular example, the customer was interested in identifying when an employee was going to turn over in their business. This is one of our most popular business questions. Of course, employees are very expensive to most businesses, and keeping good employees is a very high priority. So a little bit about this specific use case. The customer was interested in looking at employees and how many turnover by month, basically. So you can see 3 in January 2012, etc. Another thing that the customer was really interested in identifying is how employee performance played into turnover. Of course, we think that that's very important. The customer thought that was very important, but they only measured employee performance once a year. If you just put this sort of data right in a machine learning algorithm, it will probably eliminate 11/12 of your data. So it will take the rows that are complete, and that happens to be every January. So that actually doesn't get you to the unit of analysis that you want. So we have to do significant decision making and cleanup to make that work. And there are many ways that we can clean up data. There may be too many buckets. We have to narrow that down so that we can execute the models correctly. Things may not have been measured the same way over time, so we'll want to examine that. We'll want to look at a lot of different relationships, and that's what we'll do in the data profiling. So if you have questions about this, definitely post them in the comments. I'm happy to address those, but in the interest of time, we'll gloss over some of them. We also look at bivariate relationships. So up above, we're just looking at one variable at a time. Now we're looking at 2 variables at a time. And these correlations tell us what kinds of things can go in a data science model together and what kinds of things might not work out so well. It gives us a lot of other insights and information, but this is one example of the types of analysis we'll do on data to know that it's ready and mature enough to go into a data science model. Once we're all comfortable with what the data look like, we can move on to modeling. The other thing that we can do is we can set alerts around all of these cards that we've built. And if data are coming in from the source system in ways that are out of range or creating outliers or something like that, we can set up alerts so that you'll know before any of that goes into your production data science models. And then that eliminates some modeling problems in the future. And Domo makes that very easy to do. It's one of the easiest tools to do that sort of thing. And so that's something I appreciate about Domo in terms of doing data science. We can then move on to modeling. So we'll start off with a couple of things. The first thing we're going to do is ask the customer, how are you measuring employee turnover today? How are you estimating it? How do you know when somebody's going to turn over? And based on those answers, we'll put together a baseline model. In this particular case, the customer was not measuring it at all and not predicting it all. So they had historical information, but they weren't necessarily predicting it moving forward. In that case, you'll pick your best measure of central tendency, which was the median in this case, and guess that for all existing employees. We would guess that they're all going to turn over at the median. We would be right 33% of the time in that particular case. So this creates a baseline from which we can build a model. So we can know if our model is good, if it's working, or if it's not, if it's worthwhile or if it's not. After we built the model, we validate it against a validation set, and we got about 72% accuracy in the model. So a huge improvement over 33%. This is a really good model. One of the things we like to talk about is, you may be wondering, well, 72% is a long way from 100%. Why aren't we looking for 100% accuracy? Interestingly enough, most data science algorithms are based on averages, and they're based on various degrees of deviations around those averages. And we're trying to account for a lot of different things at once. So it is a complicated science involved in that. But if you are predicting on a validation set with 100% accuracy, there's a very good chance that we've overfit the model to that particular data set, and it won't perform very well for you on production data. So we don't shoot for 100% accuracy. In fact, 72% on people analytics is pretty good. So the fact that we could improve over the baseline model so much was a big success. And another way to monitor that is to monitor how the algorithm performs as you use it. And we'll talk a little bit more about that in a minute. One of the great things about Domo is the cross-validation piece. This makes training and testing really easy. You can automate all of this. So for example, if you wanted to train every month, some people would want to do that, many people wouldn't. But in this particular case, for the sake of the example, we're training this algorithm every month with new data. We can set up the training data set, we can set up the validation data set, we can specify the split, and then we can get all of the fit statistics on those validation models. And then we can set alerts around them. So if our model stops performing well when new data is fed into the training data set, we can get an alert and we can know about it right away. We can know to either kill the pages that are influenced by this particular data set and data flow associated with the data science model, or we can investigate it immediately and find out what happened and why it didn't work out as well as we could. As you can see here, the model's fitting increasingly better over time, so we're not concerned about that yet. Of course, a lot of these things are going to be like a foreign language to many people who would look at this dashboard, and we want to include everybody. We want to make sure everybody understands what's going on, so we include data dictionaries about all of that so that you can share it with anyone in your company and explain it in a way that can make sense. And that's our goal. We want data science to make sense to a wide variety of users. This is the model output for a simple linear regression, and you can see what it looks like. It looks just like it would look like in any other format. This is a demo card, and it can also update live, so that's nice, of course, accompanied with the data dictionary. The prediction monitor is one of my favorite things about doing data science in Domo, so I'm excited to tell you about it. Because everything's automated in Domo in your productionized data science models, eventually you'll be able to take predictions that you So in this particular case, we would predict when an employee was going to leave the company. And eventually, when they do leave the company, we'll be able to test whether or not our predictions were right or wrong. And we've used business logic that was specified by the business in this particular case to determine the range around the number of months that we predicted for accuracy purposes. And 68% of our predictions were correct. And if you reference that against our validation set at 72%, we're very close. So it's performing in the wild as we would expect based on our validation. And some of these we've overestimated, some we've underestimated. It gives us the flexibility to go in and see why we've perhaps over or underestimated. And if there's anything similar among the over and underestimated relative to the correct predictions, we can then get information going back into our model and feed that back into our model and give us ideas about tuning that and fine tuning it and creating better predictions in the future. Another thing that's really great about this is if we're doing data science right, we're actually using it. We're using the information. So if we know an employee is going to turn over, or our model predicts an employee is going to turn over and they're a valued employee and we want to hang on to them, hopefully there will be an intervention of some sort. Therefore, as those interventions work, if those interventions are not measured in the model that we're already running, this model will fit worse over time because we're doing better at using the model that we had. So that'll be an indication, it will show up here, of when we need to go back and retrain that model and revisit what we're doing and evaluate all of the interventions that have been successful. All right, this dashboard is great. It's very technical. I love it as a data scientist. It's not for everyone, and it certainly doesn't take, it certainly doesn't help you make business decisions in a really intuitive way. So we have a results dashboard, and this is for anybody in your business. Anybody who's making decisions about employees could use this. We focus on who's turning over and when, an important business question, why they're turning over, and then we have an application that we can use to discover what kind of interventions might work to hang on to a given employee. I've had a lot of people tell me, so this is your data science dashboard, this is it? It looks just like a normal Domo dashboard. And my response is, yeah, isn't it great? Isn't it great that you can make data science, something as complicated as data science, look like something that anybody can use at any point in time? For me, we've failed as data scientists if we don't get to this point. So we emphasize this in our practice. We always want to get to a product and to a dashboard that is very usable, very user-friendly, and is intuitive for everyone to use. It does look like any other Domo dashboard. The difference is these are predicted things that are going to happen into the future, or that we predicted to happen in the future, where most of your other Domo dashboards are going to be historical data. Right here, we have a list of employees, and of course the colors and the color coding determine gradient. The ones in dark red are going to turn over sooner, or anticipated to turn over sooner than the ones in orange, and then farther down you see yellow. You'll see that we have a couple here in gray. And these particular employees performed poorly on their last performance review. So we're probably not going to run an intervention on them. It's nice to know who they are and nice to know that the algorithm predicted that they'll turn over. We're probably not going to do a lot about them. So the dashboard is focusing on personnel that you want to make actionable decisions. You can also use this for capacity planning. In this particular instance, we have the technology sector in the coming year is going to have the most turnover, is anticipated to have the most turnover, but immediately it's the product group that has the highest amount of immediate turnover. So they may need a little more support earlier. So it gives you some information about timing, it gives you some information about capacity, and it helps businesses plan ahead. Now, why do employees turn over? This is also a very important factor. And this is one of the things that people care about in data science, often referred to as variable importance. Here we have a list of the variables that were in the model, and the darkness of the green bar and the length of the bar indicates the strength of that relationship and the importance of those relationships. So in this particular case, management succession was the most important. If someone was in line for a management position, they were more likely to stay. And that was the strongest predictor of whether or not someone would stay. Last bonus percent, the higher the percent, the more likely the person was to stay as well. But this gives us some insights into how that model is functioning. It's also giving us some insights into the kinds of interventions we may want to run, specifically on really valuable employees that we want to hang on to. We also have built a what if analysis app, and this allows us to select a characteristic about an employee and then take a look at some levers that we could pull to keep them. So let's look at equity grants, let's look at their last base pay increase and their last bonus percent. So what this gives us is an estimate of how many months an employee is anticipated to be at the company given their last performance rating. So if you got the average performance rating, which was 4, you're likely to stay for 34 months. If we want to keep that person around a little longer, we will move their number of equity grants from 68, which is the average, to a little higher. And you can see we get an increase in the number of months they're likely to stay. And you can do that for several different scenarios at once, and it gives you some insights into what you can expect by running specific interventions on that. Again, very easy to use, and something that we train all of our customers on before we leave the engagement so that everyone in the business can understand how to use this and how it works in the wild. Because it's Domo, it's fully automated, so this will keep running automatically until you tell it to stop. As we've addressed before, data science is usually not a set it and forget it kind of endeavor, but it's definitely a set it and look at it kind of endeavor. And Domo makes it very easy to monitor your data science engagements. It makes it very easy to monitor your data science output and your models and test how they're doing, which is something that doesn't often happen in the world of data science. And Domo makes it really easy. With that, this concludes my demo. Thank you for joining us. And if you want to know more, you can absolutely contact your favorite Domo rep or contact Andrew. And with that, I'll turn it back to him so we can do question and answers.
Awesome. Thanks, Christy. We have several questions. So we might do, I'll bet we could do rapid fire through all of these. The first is, can we specify more metrics to evaluate the models besides the ones that you provided on the model monitoring dashboard?
Absolutely. Domo is flexible enough to do pretty much whatever metrics you want. Those were the ones that we selected based on the business use case needs, but we can do a lot of different ones, and many of them will be determined by the algorithms we select.
Perfect. The next question was, how long did it take to go through all of this, to create all of this? And I'm assuming that's just a general question on how long do these consulting engagements take. So I'll let you answer that generally.
That's a great question and a hard one to answer. So my most favorite and least favorite answer ever is it depends. So the biggest part of these engagements, this is probably not a surprise, data readiness is a big deal. So the data have to be ready for those data science models. And if it's not ready, we have to spend a lot of time cleaning it. So customers who are ready and have data that looks good and there's not a lot of missing data, it's measured on the same granularity, they know where all the data live, and the data architecture is already in place to do data science, those go pretty quickly. It's about 12 weeks to get the algorithm dialed in and the dashboards put together. If the data are not ready, and I've been looking for the perfect data set for 25 years and I've never seen it, so most of the time data sets need a lot of work, and that will take some time, and it just depends on the quality of the data and the sources of the data and how much there is to work with.
Perfect, thanks. The next question was, what model did you use here in this employee retention demo?
So that's a great question. In this particular, so in this demo, this is based on real data, but not data. I did not show you real customer data, of course. So these are all stood up to look nice in there, but it's just based on some algorithms that we did. So I did not actually go into detail and show you those, but I can talk about them. I did 13. I ran 13 different algorithms, and with the help of the customer and the data science savviness of the customer, we settled on one that was going to be the best and the easiest for them to maintain. And it also happened to be, I think, the second most accurate. And the other one that was more accurate wasn't more accurate by much. So this was the easiest to maintain. We ended up with a linear regression. And after a lot of data manipulation, that was the best fit for this particular algorithm, and it worked really great, and it's still performing really well, so we're very happy with it. But we look at a lot. We'll look at a lot of different algorithms and make sure we dialed into the right one.
Perfect. This next question, if you understand the question, Christy, I don't actually understand the question, so you might need to explain the question to me and then answer the question. But the question was, are the values given by the feature importance interpretable?
I love this question. This is a great question. Yes, they are interpretable, but the way that variable importance tends to work in the data science world, they're not directly interpretable in the way that you want. I would create them differently. This happened to be what the customer wanted, so I'm very happy with that. That's great. In this particular case, because we use linear regression, you can standardize the values so that they are interpretable, and you can look at size of the impact as well as the coefficients. That doesn't always happen with every single algorithm, but you could do it with this one. Generally, when I look at feature importance, generally what you want to do is just say, oh, okay, the big number is more important and the little numbers are less important, but it's hard to calculate the exact size of those importance measures without some kind of standardized process so you can compare the variables in your model.
So to say it, I'm going to dive into that question a little bit more just for my own benefit. So like in a linear model, you got the y equals mx plus b, right? That's the linear model, if you will, the equation. What you're saying is that it's interpretable when we can understand what m means, and the importance of that is how big is m. Is that correct?
I would say yes, with several caveats. What people want to look at in terms of feature importance or variable importance generally is the magnitude of that effect. And your coefficient doesn't actually give you that, because all of the coefficients are based on the scales of the input variables, and all the inputs are not necessarily on exactly the same scale. In this case, they certainly were not. They were not on the same scale. So if you standardize those coefficients, then they are on the same scale, and you can look at them as that way, and they're interpretable that way too. What the feature importance does, though, and variable importance, which is the standard algorithm that most people use in a linear regression, and for different types of regression, it's done differently, but it takes the absolute value of your t-test associated with that estimate. So it's not as interpretable as other ways to do it, and I would actually prefer standardized coefficients, but not everybody is in my camp, so so I don't always win on that one, but that's what I do, if that makes sense.
Yeah, thanks for explaining that. I appreciate it. So we actually had several questions that all kind of tie to the same idea. So I'm actually going to read all of the questions kind of as one question, because they all kind of lump into the same general question that people have. The question is, how do we know if our data is good enough or ready for data science? How clean does data have to be? If we have a lot of attrition data, but the performance data is fragmented due to the different accounts we support, how do we go about creating a good data set with some predictive ability?
I love that so many questions were asked about this. It's to me, if you want to do data science, it is the singular most important question that you can ask. So I think by virtue of asking the question, you know you're on the right track. I love working with customers who are self-aware about their data. So let's dig into that a little bit. How do you know if your data are good enough? Well, if you're not a data scientist, you might not. So one good way is to ask. Is to ask somebody to take a look at it for you. And we can definitely do that. That's something that I always recommend. I love that. I think it's a really good approach to think through data quality before you move forward with an expensive endeavor that could be data science. And you want good answers. You don't want data science that's architected around poor quality data. So the first thing that I would do, and my check, and every time I work with a customer, is, do you have data that you can build a report on and deliver it to your CEO, your CXO, your CFO, whomever, and be very, very confident that that data source and those data tell exactly the right, correct, honest story. So if you can do that, you're in really good shape. You should move forward with data science. The next thing that I want to talk about is, as I said before, I've been doing this for 25 years and I've been looking for the perfect data set and I've never found it. So you're never going to have perfect data, ever. If you're waiting to do data science until you have perfect data, you'll never do data science. It's just the nature of the world. We have messy data. We live in a world with tons and tons and tons of data, and it's hard to control it all sometimes. So that's the first step. The second thing I would say to do is, once you know what kind of things you want to estimate or an outcome that you're really interested in manipulating, identify all of the variables or all of the inputs that you think are related to that, and go check out and see if you can build reports on all of those and you're really confident in the results. And if you are, you're ready for data science. Your data will not be data science clean, but it's clean enough to get started. If you feel like you've got a lot of problems with the data, if you feel like there's a lot of missing data, if you feel like things are under or overrepresented and don't tell an accurate view of the world, we probably want to start with data cleanup and data pipeline before that. And again, that's something else we can help with before we get to that point. Does that answer the question sufficiently?
I think it does. Yeah, I think that's a great answer. I think it's also important to note that with our data science consulting engagements, we actually have 3 SKUs. One of those SKUs being a data readiness exercise. So if you still, after that answer, you're like, oh, I don't know if we're ready, we can do that initial data readiness exercise with you to evaluate whether you are, and that can tie into the overall engagement. Chris, do you want to talk more about what that looks like?
Yes, that's one of our favorite engagements at Domo. It was one that I thought everybody needed to do before we did a full-blown data science engagement. So that's one that I'm happy to talk through and talk about. We have many customers who know they want to be predictive. They have heard all the buzzwords and they know that that's something that their business would benefit. They understand that that's the next step in your data journey, and have questions about, am I measuring the right thing? I know what I want to look at. I know what I want to predict, but I don't know if we've got all of the pieces in place to do it. So we can go in, we can take a look. And our consultants are very good at that piece of it because we're also business consultants. So we can take a look at that. We also are data pipeline consultants. We have experts in these fields on our team that can do that and walk through that. Our customers learn a lot, and we do that data profile and understand exactly where the data are and where they're coming from and how they look together. A lot of times you've got different pieces of data and a lot of different sources, and we finally get them together in one place, and that might be the first time a customer ever sees all of those data sources together in one place. It's a really good exercise. I haven't had anyone walk away from that and say that they felt like it was too aggressive and not a very good use of time. Almost everybody walks away from it and says, wow, I did not know what I didn't know about our data. And then they do, and we have really good recommendations for how to move forward. The other thing I really love about Domo is we're not here to sell data science at any cost. We are here to make sure that you are successful in your data journey, and we're going to lead you to the right place for you to be successful in that journey. So we want our customers to have a really good experience with that.
As a natural extension to that, it actually is a good segue into the next question, I feel like. The next question was, are the data science products in Domo offered at an additional charge? How do you charge for data science? And I think I'm going to lump into that. What are the other 2 SKUs? So I'll tackle the first part of that question and have Christy, pile on afterwards with the description of the other 2 SKUs. So the other 2 SKUs, just to preface, like I said, we do a data readiness exercise, really valuable process to go through in order to consider, what you might want to do as your use case. We have a full use case implementation, right? So if you have a specific predictive use case that you would like to implement, we can do that as a project. And then the third SKU is an experimental design. So we'll have Christy talk more about those here in a second. But yes, the data science products are offered at an additional charge. The actual tool set that Christy was showing you, the scripting tiles and the data science widgets in Magic ETL come at an additional fee. And then the data science consulting SKUs, those come in as an additional fee. Obviously they're consulting, but they're fixed bids, right? So based on the use case that you have, we'll submit a fixed bid. We're not going to be charging by hour. You won't have to worry about cost overruns or anything like that. We give a fixed bid and we complete the project with those dollars, so you don't have to worry about your total cost of ownership. Chris, do you want to dive more into the other two SKUs?
Yes, so we talked about the data science readiness assessment. You don't need the data science toolkit in Domo for that particular one. I think that the deal right now is that we will turn it on for free during that trial period, so we can figure out if that's going to be a direction that you want to go. We also have the data science engagement, which I walked through today, so I think you have a good handle on that one. The other one, which is new and something that I've done many times in my career, but and we're expanding into that world in Domo as well, is getting to causation. So most of your data science algorithms are not going to get at causation because we haven't set up an experiment in a way that we can do that. So we'll get at correlations, but oftentimes after you look at your data, the very next step in your data science journey is to take a look at how you can further explore and examine causation. And we can do that through experimental design and other types of design. And we have experts on our team who can set those up and help you run them. And that often involves the next layer of a surety that you need to move forward with a lot of the business decisions that you're making.
All right, so for anyone that has a lingering question, now's your time to get it in. We only have 2 more questions to go through. So if you have one that's just lingering, it's time to send it over. Second to the last question I have right now, often with data science, we can get data sets that are predictive, but don't explain how we came to that answer. It's kind of a black box. So how do you create a data set, such as your example, showing the how?
So I admit that I'm still trying to wrap my head around the question. I guess one of the best answers I can give you is that I don't think it's a good opportunity to move forward with data science if the inputs aren't something that we can act on and that we don't fully understand to begin with. So I think that going back to how do we know if we're ready for data science, I think that's another thing that we'll want to know about our data is, are the things that we measure, and do we understand all of the things that we measure to an extent that if they are predictive in a model, that we know why they would be, or we know something about those levers, we know something about the way those are created and how they interact together. I think this question also highlights something that is often overlooked in data science, and that is really, really good data science is based on amazingly good business acumen and business knowledge. And if we don't have those things in place, then it's really hard to move forward with data science, because you can get a data science model. Math will be calculated on data all the time, but whether or not that's useful or not is another story. So we really focus on business consulting, starting with really good questions, matching the data to those really good questions, and then building the model from that to avoid exactly this problem that I think that we're talking about. So I think that if we're at the end of an engagement and we still feel like it's a black box, we just haven't done our job very well. And we need to go back and we need to really think about the business side of that again. I think this highlights another really important feature of when you're partnering with Domo, especially Domo Consulting. We know a lot about business and we've been consultants for a long time, but we don't know your business. And so it's very useful to have someone partner with us on the customer side who understands the business, so that we get the best of both worlds. We get the data science knowledge, we get general business knowledge, but we also get very specific knowledge about the business that we're looking at. And that makes for the very best engagements. It makes for the very best results.
The last question that I have here, it comes at the same topic that I feel like we're kind of circling around, which is the data. But I feel like it comes at it from a different angle, so I didn't include it in any previous questions. The question is, how do you know what data you should use or curate for your modeling? How do you know what's going to be a good predictor?
It's another really great question. You don't always know what's going to be a predictor. So what we start with is what I call a conceptual model. And we take a look at all the possibilities. We know what the outcome is that we care about, or generally that's the case. We can often start with that. And then we'll brainstorm about what could be all the predictors. And maybe it's things that you do measure, maybe it's things that you don't measure. I counsel everyone to think beyond their actual data when they do this exercise. One of the reasons for that is because every data science model is estimated with error. We can't do anything about that error often, but if we understand it, if we understand what could be part of that error, it really helps us understand the modeling process to begin with. So I start with what I call a conceptual model, a conceptual design, and we just think of everything. What are all of the different things that could go into that? And then we start looking at, are we measuring them? And are we measuring them well? And if the answer is yes, then great. If the answer is no, then we start talking about, well, what could we do to make up for that fact that we don't measure that well? Is there a proxy that we could use? Or is there an estimation that we can incorporate so that we can model that? So there are often a lot of things that we can do around data that is not perfect, but might be good enough. And so I guess that's what I would counsel people to start with.
I hate to brag, but we nailed this perfectly on our time. That was the last question. It's 10:45. Thank you all for coming. If you have any questions, again, reach out to your favorite Domo rep or me directly. We look forward to working with you. Have a great day.